Good morning, students. Today we are going to read in chemistry subject the topic metallic bonding. So concentrate yourself. We are going to start. Metals are electropositive elements. That is, metals have a tendency to lose their outermost shell electrons in order to achieve a noble gas configuration. The atoms of a metal contribute their valence electrons to form a sea of the electrons. These electrons move freely among the positive metal ions that are arranged in regular crystal lattice. Electrostatic attractions between these electrons and the positive ions form what is called metallic bonding. The sea of the electrons help to cement the positive ions together to give metals a giant metallic structure. Figure shows the metallic bonding in sodium metal. Here are sodium ions, and this gray portion is sea of electrons. The strength of the metallic bonding increases with, very important question, increasing positive charge on the ions in the metallic lattice, decreasing size of the metal ions in the lattice, increasing number of the mobile electrons per atoms. Now we are going to read the properties of the metals. Metals conduct electricity in both solid and molten states. Metals conduct heat. Most metals have high melting and boiling points. Metals are ductile, that is, can be drawn out into wires. Metals are malleable, that is, can be hammered into shapes. Metals are hard and dense. Metals conduct electricity and heat because they have mobile electrons to carry electricity and heat energy. Very important short question, frequently come in the paper. The reason is they have mobile electrons to carry heat and light energy. Electrons move towards the positive charge. These free electrons can also transfer heat through metals quickly. Metals have high melting and boiling point because of the very strong electrostatic forces of the attraction between the sea of the electrons and positive metal ions. Metals are ductile and malleable due to the orderly packing of the metal atoms. The layers of the atoms can slide over each other easily whenever a force is applied. And this is the diagram representation. When a force is applied, layers can slide over each other. Now here comes a question. Substance X has melting point higher than 500 degrees C. It is insoluble both in water and in organic solvents. It conducts the electricity both when solid and when molten. What could X be? So it is copper, is a metal that conducts electricity in both solid and molten states. All other are non-metal. Exam tip for you people is, realize that no aqueous state for copper exists as it is insoluble in water. And other question is, Use your knowledge of the structure and bonding in aluminium to explain why aluminium is used to carry electricity in power lines. Very important question. Aluminium has an electron configuration of 283. Each aluminium atom will lose 3 valence electrons to achieve a noble gas configuration. The positive aluminium ions are arranged in a regular three-dimensional lattice in a sea of the electrons. The electrons in the sea of the electrons are free to move throughout the lattice structure. Electricity is the flow of the electrons. Hence, when electrons enter the wire from one end, they will push the electrons in the sea along the wire to the other end. A current flows in the wire. Very important question, frequently come in the paper. Very important question, frequently come in the paper. This is the comparison of the properties of simple covalent, macromolecule, metallic, and ionic. So we are going to compare the properties. First property is particles present. In simple covalent, simple molecules are present. In macromolecule, atoms are present. In metallic, positive ions in a sea of the electrons are present. And in ionic, ions are present. Next property which we are going to compare is bonding between the particles. In simple covalent, weak van der Waals forces of the attraction. In macromolecule, strong covalent bonds are present. In metallic, strong metallic bonds are present. In ionic, strong ionic bonds are present. Next property which is going to be discussed is melting point. Simple covalent bonds have low melting point. Macromolecules have high melting point. Metallic have high melting point. Ionic have high melting point. Next is electrical conductivity in solid state and molten state. In simple covalent, they have poor electrical conductivity in solid state and also poor conductivity in molten state. Macromolecules have poor conductivity in both solid and molten state. Metallic have good electrical conductivity in both solid state and molten state. Whereas ionic have poor electrical conductivity in solid state but good electrical conductivity in molten state. And other question is here. Both carbon and silicon belongs to the same group in the periodic table. When carbon combines with oxygen, a gas, carbon dioxide, CO2 is formed. However, when silicon combines with oxygen, a solid, silicon dioxide, is formed. Explain this difference in physical state. So, very important question. When carbon combines with silicon, a gas is formed. Whereas, when silicon combines with oxygen, a solid is formed. Why is this physical state? Why is this change in physical state? So, answer is carbon forms this form of the bonding with the oxygen. Carbon dioxide is a simple covalent molecule having simple molecular structure. The weak van der Waals forces of the attraction between the carbon dioxide molecules are easily overcome and hence need only a small amount of the heat energy to do it. Hence, carbon dioxide has low melting and boiling points. It exists as a gas at room temperature. And here is the structure. This is the structure of the silicon and oxide. Silicon dioxide is a giant molecule. All the atoms in the molecule are held together by very strong covalent bonds to form a giant three-dimensional lattice. A lot of heat energy is needed to break the billions of the strong covalent bonds. Hence, silicon dioxide has very high melting and boiling points. It is solid at room temperature. Another question is here. The diagram shows our arrangement of the electrons in the outer shells of the atoms in compound YZ2. Which pair of the elements could be YZ2? So here are the choices A, B, C, D. The answer is D. Y could be sulfur and Z could be chlorine. The reason is sulfur has two valence electrons to share with two chlorine atoms, each with one valence electron to share. Exam tip is option B also forms a covalent bond. However, double bonds are formed. That is this. Since carbon has 4 valence electrons to share, while each S has 2 to share, the covalent bonding resembles that of CO2 since S and O are from the same group in the periodic table. And other question is here, in which of the following pairs do the elements form a compound by sharing electrons? The answer is A, carbon and chlorine. Both carbon and chlorine are non-metals, so this is the reason. They're sharing electrons. Exam tip is neon and oxygen are also non-metals. However, neon is noble gas with a stable octet structure, which means it does not undergo any form of the chemical bonding. Neon exists as atoms. So students, this was the topic. Read it very carefully. Make your notes. Thank you so much.